So good morning. So I posted the solution to the midterm online, all right? So you can have a look there. So today we're gonna continue the Laplace transform of this continuous function. All right. So last time we were solving this equation. Is equal to FGT y0 is 0 and y prime is 0 is 1. So we were doing this, right? And the function gt is 1 when 0 is smaller than t and is smaller than 1, and 0 when t is bigger than 1. So this function is like this. So this is 1, this is 1, right? So this is gt. All right? And then in the last class we discussed that this gt will be ht minus ht minus 1, right? So this is what we did last time. So now we're gonna try to solve this equation using the Laplace transform, right? 2y is equal to the Laplace transform of ht minus the Laplace transform of ht minus 1, right? So I explain again. This is the equation that we were trying to solve last time. You have y second plus 2y prime plus 2y is equal to gt. G0 is 0 and g prime 0 is 1. The function gt is 1 when t is going from 0 to 1, and it is 0 when t is bigger than 1. So this gt will be the difference between the ht and ht minus 1, as we discussed last time. So now what we do is to do the Laplace transform on both sides of this equation. Now, so what is the Laplace transform of ht? Yes?
1 over s.
Yes. Can you stand back to this? So the Laplace transform of of ht will be 1 over s. What is the Laplace transform of 1 over t minus 1? Yes?
1 over s minus 1 or s plus 1?
Yes?
Is that one e to the negative s over s?
Yes, can you stand back to paper, please? So e to the minus s over s, right? Because the Laplace transform of ft minus c will be e to the power minus s times Laplace transform of f. This is the formula that we use, right? Explain again. Now the Laplace transform of ht is 1 over s, right? This is correct. And the Laplace transform of ht minus 1 is e to the power minus s over s, because the Laplace transform of ft minus c will give you e to the power minus sc times the Laplace transform of f, right? In this case, Laplace transform of f is 1 over s. All right? So now I have to compute the Laplace transform of y second. What is the Laplace transform of y second? Yes?
S squared times the Laplace transform of y minus s times y0 minus y prime 0.
Yes, can you stand at the back paper, please? So this is s squared Laplace transform of y minus s y 0 minus y prime at 0, right? And what is it? Yes?
S squared times the Laplace transform of y minus 1.
Yes, can you stand at the back paper, please? So this is s squared times Laplace transform of y minus 1, because this is 0 and this is 1. All right? So you replace boundary condition here, and you found this Laplace transform, right? So you have Laplace transform y second is s squared Laplace transform y minus s y0 minus y prime at 0. y0 is 0, and y prime at 0 is 1. So I replace everything here and I have s squared Laplace transform y minus 1. All right? What is Laplace transform y? Prime. Yes? Yes, can you sign the back paper, please? So this is Laplace transform y minus y at 0. And what is this value? Yes?
Oh, it's just S Laplace transform of y.
Yes. Can you sign the back paper, please? So this gives you only the s Laplace transform of y because the other guy is 0. Right? So now I'm going to put everything together. So I have Laplace transform of y second plus 3 times Laplace transform of y prime plus 2 times Laplace transform of y is equal to Laplace transform of ht minus Laplace transform of ht minus 1. And I'm going to replace everything that I found over there to this equation. So here I have s squared Laplace transform of y minus 1, which is this value. I have 3 times s Laplace transform of y plus, and then 2 times Laplace transform of y, and this is 1 over s minus e to the power minus s over s. All right? Right, so I explain again. Now I'm going to replace all of the computation that I did here into the equation. I replace Laplace transform y second to be s squared Laplace transform y minus 1, 3 times Laplace transform y prime with 3s Laplace transform y. These two Laplace transform y is the same. Laplace transform of h is 1 over s, and Laplace transform of t minus ht minus 1 is e to power s over s. Right? So what is the next step? Yes?
You factor out the Laplace transform of y on the left side.
Yes, can you stand back paper, please? So now I have s squared plus 3s plus 2 times the Laplace transform of y minus 1 is 1 over s minus e to power minus s over s. Right? So now what I did is to factorize all of the terms that have Laplace transform of y. Right? So here I have s squared, 3s, and 2. So I have s squared minus plus 3s plus 2 times Laplace transform of y. This is minus 1, right? This is 1 over s minus e to power minus s over s. Right. So what is the next step? Yes?
Do you add 1 to the other side?
Right. So here I have s squared plus 3s plus 2 times Laplace transform of y is 1 plus 1 over s minus e to the power minus s over s. So this is s plus 1 over s minus e to the power minus s over s. Right? So the next step, I add 1 to the other side to eliminate this minus 1, right? So I have 1 plus 1 over s minus e to the power minus s over s. So 1 plus 1 over s is s plus 1 over s minus e to the power minus s over s. What is the next step? Yes?
You're going to divide by the polynomial on the other side.
Yes, can you say it back please? So now I'm going to divide both sides with this polynomial, right? So I divide the first guy with the s squared plus 3s plus 2 minus e to the power minus s over s squared plus 3s plus 2. Right? So now I'm going to divide both sides with this polynomial. So the Laplace transform of y will be s plus 1 over s squared plus 3s plus 2 minus e to the power minus s over s squared plus 3s plus 2. What is the next step? Yes?
Take the inverse Laplace of both sides.
Right. Can you sign the paper, please? So y will be the inverse Laplace transform of s plus 1 over s squared plus 3s plus 2 minus the inverse Laplace transform of e to the power minus s over s squared plus 3s plus 2. Right? And what should I do next? Yes?
Can we factor the s squared plus 3s plus 2 terms so we can use partial fractions to
Right.
solve the inverse Laplace
Can you
transforms?
hand the back the paper, please? So now I'm going to have to factorize this s squared plus 3s plus 2. All right? So s squared plus 3s plus 2 will be what? Yes?
S plus 2 and S plus 1.
Can you send back the paper, please? So s squared plus 3s plus 2 will be s plus 1 times s plus 2, right? So I'm going to plug that here. So I have y will be the inverse Laplace transform of s plus 1 over s plus 1 times s plus 2 minus inverse Laplace transform of e to the power minus s over s squared plus 3s up s plus 1 s plus 2. Right? I explain again. So the next step we're gonna factorize s squared plus 3s plus 2 as s plus 1 times s plus 2. And I plug it back to this formula, right? So I have the inverse Laplace transform of s plus 1 over s plus 1 s plus 2 minus the inverse Laplace transform of e to the power minus s over s plus 1 s plus 2, right? So what is the next step? Can we simplify this expression a little bit? Yes?
Well, in the first term, you can cancel the s plus 1 from the
Yes.
top and the bottom,
Okay.
and then you can use partial fractions.
Yes. Can you send back the paper, please? So in the first guy, I can cancel s plus 1, right? So this gives me the inverse Laplace transform of 1 over s plus 2 minus the inverse Laplace transform of e to the power minus s plus 1 s plus 2. All right? So now I'm gonna compute the inverse Laplace transform of the first guy. To do that, I'm gonna split s plus 2 as a over s plus b over s plus 2, and this is a s plus 2 plus bs over s plus 2, which means that 1 is going to be a s plus 2 plus bs. All right? So I'm going to use partial fraction. So 1 over s plus 2 will be a over s plus b over s plus 2. And this is equal to as plus 2 bs, which means that 1 is as plus 2 bs. Right? So what is a and what is, yes?
A is going to be 1/2 and B will be also 1/2.
Minus. Can you say the back of the paper, please? So now to find a, I'm gonna put a s to be 0, right? So when I set s to be 0, I have 1 is a 0 plus 2 plus b times 2 0, and this is 2a, which means that a is 1/2, right? And b is minus 1/2. I explain again. Now I have to compute a and b. I'm going to set s to be 0. So 1 is going to be a 0 plus 2 plus b times 0. This is 2a, which means that a is 1/2, right? Right? So now s is, we're going to set s to be minus 2. So 1 is going to be A minus 2 plus 2 plus B times minus 2. So this guy goes away, so you have minus 2B. So B is minus 1/2. All right? I explain again. So you have 1 over s plus, now we use partial fraction. I have 1 over s plus 2 is going to be a over s plus b over s plus 2. So this is as plus 2 plus bs over s plus 2, right? Which means that 1 is as plus 2 plus bs. I put s to be 0. I get 1 is a times 0 plus 2 plus b times 0. So this gives me 2a. So a is 1/2. So now I put s to be minus 2. So 1 is going to be a minus 2 plus 2 plus b times minus 2, which means that b is minus 1/2, right? Questions? Now I put everything back into this expression. So I have the inverse Laplace transform of 1 over s plus 2 is going to be the inverse Laplace transform of 1/2 1 over s plus the inverse Laplace transform of minus 1/2 1 over s plus 2. Right? So what is the inverse Laplace transform of the first guy? Yes?
It will just be 1/2 because the inverse Laplace transform of 1 over s is 1.
Yes, can you say it back to this? So the first guy gives me 1/2, right? So what is the inverse Laplace transform of the second guy? Yes?
Negative 1/2 times e to the negative 2t.
Yes. Can you say the back paper, please? So this is minus 1/2 e to the power minus 2t over 2. Right? So this is the first inverse Laplace transform. All right, so we're gonna do the second inverse Laplace transform. So now you have the inverse Laplace transform of e to the power minus s over s plus 1, s plus 2. Right? Now I have to compute the inverse Laplace transform of this guy. So what should I do? Yes?
We know that the Laplace transform of f minus the constant times the Heaviside function t minus the constant, it will be e to the negative cs times the Laplace transform of f of t.
Mhm.
And so here we can see that c is 1, and
Right.
the Laplace transform of f of t will be 1 over s times s plus 1 times s plus 2, so we need to solve for f of t,
Right.
and then we can determine the inverse of that whole thing.
Right. So can you stand the back of the paper, please? So the first thing we have to do is to compute the inverse Laplace transform of this guy first, and after that we're gonna do the we're gonna shift, right? So how can I do this inverse Laplace transform? Yes?
You can separate it out like with the a, b, and c.
Yes, can you stand the back of the paper, please? So now I have 1 over s plus 1, s plus 2 is a over s plus b over s plus 1 plus c over s plus 2, right? So again, you're gonna use the partial fraction to the term that do not have exponential, and after you get it, you're gonna shift it back to the you shift it back with 1, right? So now I'm gonna have to use partial fraction, which means that I have 1 is equal to a s plus 1 s plus 2 plus b s plus 2 plus c s plus 1. All right? How can I find ABC? Yes?
So that s equal to 0 and -2.
Yes, can you sign the back of this? So first, I set s to be 0, right? To find ABC, I'm going to set s to be 0. So when s is 0, I have 1 is a, 0 plus 1, 0 plus 2, plus b, 0, 0 plus 2, plus c, 0, 0 plus 1. All right? The first thing to do is to set s to be 0. So when s is 0, you have 1 is a, 0 plus 1, 0 plus 2, plus b, 0, 0 plus 2, plus c, 0, 0 plus 1. So these guys go away, this guy go away. So I have 1 is 2a, which means that a is 1/2, right? Now I'm going to set s to be -1. So when I set s to be -1, I have 1 is a minus 1 plus 1 minus 1 plus 2 plus b minus 1 plus 2 plus c minus 1 plus 1. This goes away, this goes away. So I have 1 is b times this is minus b. So b is -1. All right? So for the next step, I set s to be -1. So when s is -1, I have 1 is a minus 1, plus 1 minus 1 plus 2, plus b minus 1, minus 1 plus 2, plus c minus 1 plus 1, right? So the first guy and the last guy go away. So what is left over is b minus b. So b is -1. So the next step is to set s to be -2. So when s is -2, I have what? I have 1 is a, -2 plus 1, -2 plus 2, plus b, -2, -2 plus 2, plus c, -2, -2 plus 1. All right? So the next step is to set s to be -2. We have 1 is a times -2 plus 1, -2 plus 2, so this guy go away. B -2 plus 2, this guy also goes away. And the leftover is just c -2 plus 1, so I have 1 is c times 2, so c is then 1/2. So after everything, I can plug ABC here. So A is 1/2, B is -1, and C is 1/2. All right? After all of this computation, I found that 1 over s, s plus 1, s plus 2 will be 1/2 1 over s minus 1 over s plus 1 plus 1/2 1 over s plus 2, right? So I'm gonna do the inverse Laplace transform now. I have the inverse Laplace transform of 1 over s, s plus 1, s plus 2 will be 1/2 the inverse Laplace transform of 1 over s minus inverse Laplace transform of 1 over s plus 1 plus 1/2 the inverse Laplace transform of 1 over s plus 2. So what is the first guy? Yes?
1/2.
Yes. Can you sign back of this? So the first guy is 1/2. What is the second guy? Yes?
To the negative t.
Yes. Can you sign the back of this? So you have minus e to the power minus t. What is the last guy? Yes?
1/2
Yes, can you send back to paper, please? So the last guy will be 1/2 e to the power minus 2t. Right? Right. So so now I've found this inverse Laplace transform is this guy. So what is the value for this inverse Laplace transform? Yes?
Well, it will be that function that we found, except instead of t is the variable will be t minus 1, and then
Yes.
it will be that multiplied by the Heaviside function
Yes,
at
yes.
t minus 1.
Right, can you say it back? So this guy will be 1/2 minus e to the power minus t minus 1 plus 1/2 e to the power minus t minus 1 times the Heaviside function at t minus 1, right? And then you take the sum of the two guys and you get the solution. Questions? It's clear? Right. Right, so now the solution will be the sum of this guy and the other guy. So basically the solution will be 1/2 minus e to the power minus 2t over 2 plus 1/2 e to the power minus t minus 1 plus 1/2 e to the power minus t minus 1 h t minus 1. Right? Any questions on this exercise? So if there is no questions, let's go. Let us continue with another equation. So now we have example. You have y second minus y is going to be gt. Y is 0 is 0. Y prime is 0 is 0. And gt is a function which is 0 when t is smaller than 0 and smaller than 1. This is 1 when 1 is going to be t. T is bigger than 1, smaller than t, and 2 when t is bigger than 3. All right? So for the next step, we change the source term, and we have a new equation. Right? So I explain again. We have y second minus y is gt. Y0 is 0. Y prime is 0 is 0. The gt will be 0 when t is going from 0 to 1. This is 1 when t is from 1 to 3, and this is 2 from t is bigger than 3. So this is basically the gt. So from 0 to 1 is 0. From 1 to 3 is going to be 1. And this is going to be 2 when this is bigger than 2. Right. So what is we have to express g in terms of the sum of Heaviside function. So what is the Heaviside function that we should consider? Yes?
Is it h of t minus 1 plus h of t minus 3?
Yes. Can you sign back paper, please? Yes, S of t minus 1, right? Wait a second. So let me change this to 2. Right? To here. This is 2 here, right? So what is the form of G? Can you say at the back, please? So now I have what? I have a function which is 1 from 2 to 3 and 2 from 3 to infinity. What is the so I have to express this function in terms of the Heaviside function, or the sum of Heaviside function. So how can I express this guy as the sum of Heaviside function? So this is going to be 2 from here to infinity, from here to here. It's going to be 2 from here to infinity. So what is the expression that we can write? Yes?
Is the first term still when t is
Sorry,
less than
2.
1, or is that also a 2?
Yes, can you sign my paper, please? Right. So how can I express the function g? Yes?
Is it just h of t minus 2 plus h of t minus 3?
Yes, can you sign the back of the paper, please? So the function g will be h of t minus 2 plus h of t minus 3, right? Right, so because this function, when t is smaller than 2, this gt is 0 because both of those functions will be 0, right? Because h of t minus 2 is h of t minus 3, and then 0, right? So when t is smaller than 2, both functions ht minus 2 and ht minus 3 are 0, so g should be 0. So this is like what we have here, right? Now when t is from 2 to 3, the first guy is 1 and the second guy is 0. So gt has to be 1. So ht minus 2 is 1 and h of t minus 3 is 0, right? So which is from here to here, right? And when t is bigger than 3, gt has to be 2 because both of them are 1. Right? Right, so I explain again. I have a function which is 0 from 2 to 0 to 2. This function is 1 from 2 to 3, and it is 2 from 3 to infinity. I have to express this in terms of Heaviside functions. All right. So a reasonable decomposition is ht minus 2 plus ht minus 3. Why? Because when t is smaller than 2, both of these guys are 0, which is the situation that we have here. When t is from 2 to 3, the first guy is 1 and the second guy is 0, which means that you have 1. This is also the situation that you have here. Now, when t is bigger than 3, both of them are 1, so gt is 2. Any questions? Good. Right. So this is the gt that we have. And we have what? We have equation y second minus y is ht minus 2 plus ht minus 3. This is the equation. What is the next step?
So,
Yes?
take the Laplace of both sides?
Yes, can you say the back paper, please? So now I'm gonna take the Laplace transform both sides. What is the Laplace transform of ht minus 2? Yes? Yes. Yes, can you say it back please? So this is e to the power minus 2s over s. What is the Laplace transform of ht minus 3? Yes?
E to the negative 3s over s.
Yes, can you say it back please? So this is e to the power minus 3s over s, right? What is the Laplace transform of y second? Yes?
It's s squared Laplace transform of y plus s y0 minus y prime 0.
Yes, you can say it back please. So you have s squared Laplace transform of y minus s y0 minus y prime at 0. So what is the value of this expression? Yes?
It's just s squared, Laplace transform of y.
Yes, can you say it back please? So this is s squared Laplace transform of y. Now I put everything into the equation. I have s squared Laplace transform of y minus Laplace transform of y is equal to e to the power minus 2s over s plus e to the power minus 3s over s. All right? So I explain again. Now the first thing that I have to do is to write this forks in terms of Heaviside function. So the forks will be ht minus 2 plus ht minus 3. All right? Now I have to do the inverse Laplace transform on both sides of this equation. So I have the inverse Laplace transform y second minus Laplace transform y is the Laplace transform of ht minus 2 plus Laplace transform of ht minus 3. Right? So the Laplace transform of ht minus 2 is e to the power minus 2s over s. The Laplace transform of ht minus 3 is e to the power minus 3s over s. Laplace transform of y second is this guy, but all of those are 0, so you have s squared Laplace transform of y. So I put everything into the equation. I have s squared Laplace transform minus Laplace transform of y is e to the power minus 2s over s plus e to the power minus 3s over s. So what is the next step? Yes.
You factor out the Laplace transform of y and then divide by s squared minus 1.
Yes, can you set the factor please? So now I factorize the left hand side. I have s squared minus 1 have Laplace transform of y e to the power minus 2s over s plus e to the power minus 3s over s. Right? And now I divide both sides by s squared minus 1. So Laplace transform of y is e to the power minus 2s over s squared minus 1 plus e to the power minus 3s over s squared minus 1. Right? I explain again. So here I write s squared Laplace transform of y minus Laplace transform of y is s squared minus 1 Laplace transform of y, and this is this guy. I divide both sides by s squared minus 1. So what is the next step? Yes?
So now we want to find the inverse Laplace transform of the 1 over s times s squared minus 1, because then we can use our formula for the Heaviside function to incorporate the exponential.
Yes, can you say it back to purpose? So now you want to compute the inverse Laplace transform of this guy, right? Plus the inverse Laplace transform of this guy. All right. So what I do now is that, okay, because here I have exponential, I can forget about exponential. I just have to find the inverse Laplace transform of 1 over s squared minus 1 first, and after that I shift using the Heaviside function, right? So how can I compute the inverse Laplace transform of 1 over s squared minus 1? Yes?
S squared minus 1 is s minus 1s plus 1. And then you can do partial fractions.
Yes, can you say it back to paper, please? So this is equal to 1 over s minus 1, s plus 1, right? And you use partial fraction. So to compute the Laplace transform of this guy, you observe that s squared minus 1 is s minus 1, s plus 1. So now you have to compute the Laplace transform of this guy, and again you use partial fraction. So you're going to write this like a over s plus b over s minus 1 plus c over s plus 1, right? You're going to write 1 over s, s minus 1, s plus 1 as a over s plus b over s minus 1 plus c over s plus 1. So which means that this is equal to a s minus 1 s plus 1 plus b s plus 1 plus c s minus 1 over s plus 1 s minus 1, which means that 1 is a s minus 1 s plus 1 plus b s plus 1 plus c s minus 1. So how can I find a, b, c? Yes?
You said s equal to 0, 1, and negative 1.
Yes, can you sign the back paper, please? So now I'm gonna set s to be 0. Right? So when I set s to be 0, have 1 is a, 0 minus 1, 0 plus 1, plus b, 0, 0 plus 1, plus c, 0, 0 plus 1. Alright? So the first thing you do is you set s to be 0. When s is 0, you have a 0 minus 1, 0 plus 1, b 0, 0 plus 1, c 0, 0 plus 1. This is 0. So then you have 1 is minus a. So a is minus 1. So what is the next step? Yes?
Set s equal to 1 and then b would be 1 half.
Yes, can you sign the back paper, please? So now you set s to be 1. So you have a 1 minus 1, 1 plus 1, plus b 1, 1 plus 1, plus c 1, 1 minus 1. The next step, you set s to be 1. When s is 1, the first guy goes away, the second guy goes away. So you have 1 is b times 2, which means that b is 1 half. And the next step is what? Yes?
You set s equal to negative 1.
Yes, can you say it back to paper, please? So now you're going to set s to be minus 1. So when I set s to be minus 1, I have 1 is a minus 1, minus 1, minus 1 plus 1, plus b minus 1, minus 1 plus 1, plus c minus 1, minus 1, minus 1. Right? The next step, I set s to be minus 1. So here I have a minus 1, minus 1, minus 1 plus 1, minus 1, minus 1 plus 1, c minus 1, minus 1. So finally I have 1 is c times 2, which means that c is 1 half. Alright? So I replace everything here. A is minus 1, b is 1 half, c is b is 1 half, c is 1 half, c is 1 half. Right, so after all of this computation, I found a is minus 1, b is 1 half, c is 1 half. I can write this at like minus 1 over s plus 1 half, s minus 1 plus 1 half, s plus 1. Right, so now the inverse Laplace transform of this guy will be minus the inverse Laplace transform of 1 over s plus 1 half inverse Laplace transform of 1 over s minus 1 plus 1 half the inverse Laplace transform of 1 over s plus 1. So what is the inverse Laplace transform of 1 over s? Yes?
Minus 1.
Yes, can you sign the back paper, please? So this is minus 1. What is the inverse Laplace transform of 1 over s minus 1? Yes?
1 half e to the t.
Yes, can you sign the back paper, please? So this is 1 half e to the t. What is the inverse Laplace transform of the other guy, the last guy? Yes?
1 half e to the negative 2t.
Yes.
Or negative, wait. E to the 1/2 e to the negative t.
Yes, can you sign back paper, please? So the last guy is 1/2 e to the power minus t, right? So now you just apply the formula that you have. Inverse Laplace transform 1 over s is 1. Inverse Laplace transform 1 over s minus 1 is e to the t. And inverse Laplace transform of 1 over s plus 1 is e to the power minus t, right? Right. So now this is the inverse Laplace transform of this guy. Right. So what is the inverse Laplace transform of e to the power minus 2s over s minus 1 s plus 1? Yes.
Well, we just have to shift that function that we found by the constant term in the exponential, which is -2. So we just plug in t plus 2 in the, t minus 2 in the bottom function, and then we multiply that by the heaviside function of t minus 2.
Yes, can you sign it back paper, please? So this will be h of t minus 2 multiplied with everything which is cheap. So minus 1 is the same. 1/2 e to the t minus 2 plus 1/2 e to the power minus t plus 2. Right? Now I have to compute the second guy. So inverse Laplace transform is e to the power minus 3 s minus 1, s plus 1 will be. So what is the second quantity? Right, so for the first quantity, you multiply, you shift t to t, yes?
You would do the same thing, but shifting by, so it would be t minus 3 and then multiply by h to the t minus 3.
Yes, can you send the back copies? Right, so you just replace t minus 2 by t minus 3. And the final result will be the sum of the two, right? So y will be ht minus 2 minus 1 plus et to the power minus 2 over 2 plus et minus 2 plus 2 over 2 plus ht minus 3 minus 1 plus et minus 3 over 2 plus et minus 3 plus 3 over 2. All right? Questions? It's good. All right, so let us do another exercise. Questions? It's good, right? So if there's no questions, let us go to another exercise, which is more difficult. Right, so this time we do the Laplace transform for first order differential equation. You have y prime minus 3y is equal to gt. y0 is 1 and gt will be t minus 2, t minus 1. ht minus 1 plus t minus 2, ht minus 2. Right? So this time problem is more difficult. it is easier in the sense that the degree of the equation is reduced from 2 to 1. But it's more difficult because the forks is more complicated, right? So, so in this case, you have to solve a first order differential equation. Y second minus 3y is equal to gt, in which gt has this long form. You have one initial condition, y0 is 1. So how do I solve this equation? Yes?
Would we start by taking the Laplace transform of both sides of our
Yes.
differential equation?
Yes, can you sign the back of the paper, please? Again, we're going to do the Laplace transform. So we have Laplace transform y prime minus 3 times Laplace transform y is equal to the Laplace transform of this whole guy. So I have this plus t minus 2 s of t minus 2. And this is Laplace transform of y minus 2 Laplace transform of t minus 1 s of t minus 1 plus Laplace transform of t minus 2 s of t minus 2. And then here I have the same. Laplace transform y prime minus 3 Laplace transform y. Right? So I explain again. In this case, you have a first order differential equation. You have y prime minus 3y is equal to gt. gt in this case, t minus 2t minus 1, ht minus 1 plus t minus 2, ht minus 2. Right? So again, what you do is you take the Laplace transform on both sides. The first, the left hand side, you get Laplace transform y prime minus 3 times Laplace transform y. Right hand side, you have the Laplace transform of the whole thing. And so this split into 3 Laplace transform. So the first easy thing is, what is Laplace transform of t? Yes?
1 over s squared.
Yes, can you sign back the paper, please? 1 over s squared, right? So the first thing that I can compute easily is the first one, Laplace transform of t. So the Laplace transform of t will be 1 over s squared. Now, I have to compute the Laplace transform of the second guy. So what is this? What formula should we use? Yes?
So it's easy on us in this case because our f of t minus 1 is just t minus 1. So doesn't that mean that our function f of t is just t? And so we can use the formula, so it'll come out to be e to the negative s times the Laplace transform of t, which is 1 over s squared.
Yes, can you just hand it back to paper, please? So this is the formula that we have, right? ht minus c, ft minus c, ht minus c is e to the power minus cs, Laplace transform of f. Right? So this is the formula that we use. The Laplace transform of ft minus c times ht minus c will be e to the power minus cs times Laplace transform of f. Right? So in this case, c is 1 and ft is t. So what you have is e to the power minus s Laplace transform of t. All right? And what is this result? This Laplace, yes?
E to the negative s over s squared.
Yes. Can you sign back the paper, please? So which means that this is e to the power minus s over s squared. Right? So I explain again. In this case, you're going to use the formula. The Laplace transform ft minus c times ht minus c will be e to the power minus cs times Laplace transform y. In this case, c has to be 1 because you have t minus 1, and f is t. So this Laplace transform will give you e to the power minus s Laplace transform of t, which is e to the power minus s over t squared. All right? So for our second guy, apply the formula. Yes?
Would it be the same thing except on top it's going to be e to the negative 2f?
Yes, can you sign the back paper, please? So for the second formula, c will be 2, right? So you're going to have the same thing, e to the power minus 2s, Laplace transform of t, and this is e to the power minus 2s over s squared. So in this case, c is again 2 and ft is again t, right? So this equation needs to look more complicated, but in fact it is easier. I explain again. For the second guy, I applied this formula again with c to be 2, and the function is t. So the Laplace transform of t minus 2, ht minus 2 will be e to the power minus 2s times the Laplace transform of t. So this is e to the power minus 2s over s squared. Right? Right. So now I know what is this guy, I know what is this guy. So the thing that I have to compute is the Laplace transform of y prime. So what is the Laplace transform of y prime? Yes?
S times the Laplace transform of y plus y0.
Yes, can say at the back of the paper, please. So you have s times Laplace transform of y minus y0. All right? So what is it? Yes?
S times the Laplace transform of y minus 1.
Yes, can say back paper, please. So you have s times Laplace transform minus 1. So you plug everything back into the equation. You have s times the Laplace transform of y minus 1 plus minus 3 times the Laplace transform of y is equal to 1 over s squared plus e to the power minus s over s squared plus minus 2 minus 2 plus e to the power minus 2s over s squared, right? So the next step, you put everything back into the equation. You have s Laplace transform of y minus 1 minus 3 Laplace transform of y is 1 over s squared minus 2 is to the power minus s over s squared, and then you have e to the power minus 2s over s squared. So what is the next step? Yes?
Well, we'll group the like terms on the left side of the equation and factor out the Laplace transform and move the 1 to the other side.
Yes, can you sign the back paper, please? So in this case, you're going to group everything, right? So you have s minus 3 Laplace transform of y is going to be 1 plus 1 over s squared minus e 2 times e to the power minus s over s squared plus e to the power minus 2s over s squared. Now you divide everything by s minus 3. So you have 1 over s minus 3 plus 1 over s minus 3s squared minus 2 e to the power minus s squared s minus 3 plus e to the power minus 2s over s squared. Right? Now you're going to do the inverse Laplace transform. 1 minus s minus 3 plus inverse Laplace transform of 1 over s minus 3 s squared minus 2 inverse Laplace transform of e to the power minus s over s squared s minus 3 plus inverse Laplace transform of e to the power minus 2s over s squared. Right? I explain again. so what you do now is you group the Laplace transform of y. So this gives you s minus 3 Laplace transform of y. And then you have 1 plus 1 over s squared minus 2 e to the power minus s over s squared plus e to the power minus 2s over s squared. Now you divide both sides by s minus 3. And you found the right hand side. What we have to do now is to do the inverse Laplace transform, right? So what is the inverse Laplace transform of 1 over s minus 3? Yes?
E to the 3t.
Yes, can you sign my paper, please? Is to 3t. All right, now we have to compute the inverse Laplace transform of 1 over s minus 3 s squared. So how do I do this inverse Laplace transform? Yes?
Do we split using partial fraction?
Yes. So now you have to do the same game. You have to do the partial fraction. You have this is equal to a s minus 3 plus b over s squared. So how do I find a and b? Yes?
So you set it up so you have a times s squared plus b times s minus 3 equal to 1.
Mm-hmm. Yes, I had to make the paper this. So now you have a times s squared plus b times s minus 3 is equal to 1. No. I think I make a mistake. So I have to have, so this is second order, right? So this is bs plus c. So here I have to have bs plus c. S minus 3. Right? It's clear? I explain again. So, because this is of order 1, a is of order 0. This is reasonable. But here, s squared is of order 2. So on the top, I have to have something of order 1. So I have bs plus c over s squared. Right? So now I have to have a s squared plus bs plus c, s minus 3. How do I find ibc? I have 1 is a s squared plus bs plus c times s minus 3. How do I find ibc? Yes?
So s equals 0 and then s equals 3.
Yes, can you sign the back the paper, please? So first I said s is equal to 3. So when s is equal to 3, I have 1 is a 3 squared plus b times 3 plus c times 3 minus 3. Right? So the first thing I do is I set s to be 3. When s is 3, I have a 3 squared plus b 3 plus c is 3 minus 3. So this guy go away. So I have 1 is 9a, and then a is 1 over 9. This is one guy, right? So then I have 1 is s squared over 9 plus bs plus c times s minus 3. Right? So what is the next step? Yes?
Let s equal to 0.
Yes, can you sign the back of the paper, please? So now I'm going to set s to be 0. So when s is 0, I have 0 squared over 9 plus b times 0 plus c, 0 minus 3. Right, so this goes away, this goes away, so I have 1 is c minus 3, c is then minus 1 third. Right? So the next step, I'm going to set s to be 0. When s is 0, 1 is 0 squared over 9 plus b times 0 plus c times 0 minus 3. The first two lines go away. So I have c 0 minus 3, which means that 1 is c minus 3, c is minus 3, 1 over 3. Right? So now I have what? I have 1 is n squared over 9 plus bs plus minus 3 S minus 3. So what is B? The hint is that you look into the order of S squared. So what is the order of, so what is the coefficient of S squared on the right hand side? Yes?
On the right-hand side, we have an a s squared term and a b s squared term, and those are two s squared terms. And on the left-hand side, we have no s squared term, so we know that b must be equal to negative a because
Yes.
they have to come to 0.
Yes. Can you sign the back page of this? So the coefficient of S squared here is 1 over 9 and B, right? So the coefficient of S squared on the right hand side is A plus B, which is 1 over 9 plus B, right? So the coefficient of S squared on the right hand side is A plus B, which is 1 over 9 plus B. And the coefficient of S squared on the left hand side of S squared on the left hand side is 0, which means that 1 over 9 plus B has to be 0, so B is minus 1 over 9. Right? So to find B, it is straightforward because you look into the coefficient of S squared. On the right hand side you have 1 over 9 plus B. And on the right hand side, left hand side you have 0. So 1 over 9 plus B has to be 0. Alright? So B is minus 1 over 9. So now I have these things. I have 1 over 9. This is 1. B is 1 minus 1 over 9. S, and then C is minus 1 over 3. All right. So this is the partial fraction that we have. Now I have to compute the inverse Laplace transform of 1 over 9, 1 S minus 3. What is it? Right? So now I have to compute the inverse Laplace transform of S minus 3 times S squared. I split 1 over S minus 3 S squared as 1 over 9 S minus 3 plus minus 1 over 9 S minus 1 over 3 S squared. Now I have to compute the first inverse Laplace transform. What is it? Yes?
1 over 9 e to the 3t.
Yes. So this is 1 over 9 e to 3t. This is easy. So for the second one, I have to compute the inverse Laplace transform 1 over 9s minus 1 third of S squared. What is it? Yes?
So we can simplify it by splitting up the numerator, because then we get a term of negative 1/9 s over s squared, which simplifies to negative 9 1 over s, so that the inverse Laplace transform of that would just be negative 1/9. And then the second term, we have a negative third over s squared, which comes out to negative third times t.
Yes, can you sign my paper, please? Right, so the first term, I have the inverse Laplace transform of 1 over minus 1 over 9, 1 over s, minus 1 over 3 inverse Laplace transform of 1 over s squared. So the first guy gives me 1 over 9. The second guy gives me 1 over 9, the one that 1 over 3t, right? So for the second inverse Laplace transform, we have minus 1 over 9s minus 1 over 3 over s squared. So the first term is s over s squared, which is 1 over s. This gives me minus 1 over 9. The second guy is minus 1 over 3 over s squared, which gives me t. Questions? right? So finally, I combine everything. I have inverse Laplace transform of 1 over s minus 3s squared is 1 over 9 is power minus 3t minus 1 over 9 minus 1 third of t. All right. So now I have, this is the second guy. This is the first guy. The next step is to compute the third guy, which is minus 2 inverse Laplace transform of e to the power minus s over s squared s minus 3. So what is it? Yes? So how can I compute the third move? Inverse Laplace transform of y. I know already the second one. Yes?
So the function that we found for the inverse Laplace transform of 1 over s minus 3 times s squared, we can use that because we can use our Heaviside formula. We can say in the first one with the exponential, c is going to be 1. So the inverse Laplace transform of that, taking into account the -2, will be -2 times that function, sorry, with t minus 1 plugged in times the Heaviside function of h of t minus 1.
Right. So to do this, we multiply this guy with st minus 1 and we shift. Right. So this is minus 2 st minus 1, 1, 9, 3t minus 1, minus 1 over 9, minus 1 third, 9. Right? That's it. Any questions? It's good. Just have back paper, please. Now, we have to do the last one. We still have 1 minute, so we have enough time for the last one. So, no, we don't have enough time, so we continue on Thursday. All right? Yes?
Can we talk about the final project?
The final